After the first one, we're going to do 3 total here as a group. Before I introduce these new proofs and why we need to do it a different way, I need you to have an ability to do these proofs, or like a prerequisite, and that is, can you find something that 2 statements that contradict each other? Okay. So up here, I have 3 statements. Triangle DEF is scalene. We remember that from our vocab in Unit 4. DEF is right. Angle D is congruent to angle F. It is geometrically impossible for 2 of these to happen at the same time. Impossible. Discuss it with your group, please. It is impossible for 2 of these to happen geometrically at the same time. What I said.
Angle, yeah, DCF and not. It's 1 and 3 because yeah, we did angle 4 that triangles are.
All right, let's talk, because I'm hearing different responses from different groups. So if you did not get the correct 2, I want to show you why it's actually geometrically possible for those 2 to happen. Do we have groups that think they know the 2 that cannot happen ever? Abby? 1 and 3 cannot happen, because take a look. D, E, and F. If I make angle D congruent to angle F, automatically what type of triangle is that? That's isosceles, not scalene. Okay. I heard some people say, how can it be scalene and right? Pretty easy. There's a right triangle. 3, 4, 5. There's scalene. Okay, so those 2 can happen at the same time. So yes, it was choice 3 and choice 1. Why am I having you do that? That's what you have to do today. That's what's going to happen in your proof. You're going to have a contradiction, something that geometrically cannot happen. All right, are we good? Throw it away. Throw it away. You guys are killing me here. I literally can't make up new seats. All right, because I have the perfect pairings here, what I think. All right, so it looks like we're going to go separation mode come Monday. All right, I'm going to introduce what's called an indirect proof. Indirect proof. And I'm look, I have the directions here, and we could read them, hold hands, right? No, we're not doing that. I'm going to throw you right into the fire. All right, right into the fire with this. Before we write anything down, I want you to look at this proof, please. I want you to look at the givens and the proof statement, because there is something very, very different than anything we've done in the last 4 units with proofs. We have never seen this before, ever. Theodore, what have we never seen here? What's giving you problems?
It says in the given that BD is not congruent to BE.
And in the proof statement too, right? I have that not equal to. Have we ever seen that in a proof this year? Never. Never have I told you this is not equal or not congruent. So that is a problem. That is why, and also that is a signal when I am asked to prove something not happening. That is a signal to us that we need to do the proof indirectly. So proof must be done indirectly, excuse me. That's a signal to everybody, because I will let you know in an honors level class, that will not be in my directions that say, hi, please do this proof indirectly. I'm not going to ask for that. You're going to have to know based on this proof statement. If you are asked to prove something is not happening, I need to do this indirectly. Now you'll notice not much has changed, right? Statements, reasons, I put my givens in. Nothing's changed until now. Step 2. If you're going to do a proof indirectly, and please just follow along with me, and I promise you I will wrap it all up at the end. After your givens, we're going to start this a little differently. We're going to start by assuming the opposite of the proof statement is true. So I'm saying that angle A is not congruent to angle C. The opposite of that would be saying that they are congruent. So that's how I'm going to start this indirect proof, by saying, hey, no, you know what? Angle A is congruent to angle C. And that is called my assumption. And I want you to see where this leads us. It leads us to a very bad place, assuming that those two are true. A very bad place. We're still doing a proof. Mark our diagram, A congruent to C, right? And then also we had another given there that we can mark, AB congruent to BC. So let's not forget our, where we came from. AB congruent to BC. Mark them with hash marks. And I want to remind you before we move on, any proof we always do all year long, including the ones we've already done in the last 4 units, the givens are always true. Whatever you're provided in a given is always true. Okay, so let's keep that in mind as we go on. So watch where A congruent to C leads us. It's going to lead us to a bad place eventually. So we have these two angles congruent. We have BA and BC. Where's this kind of leading us to here that we've already done this year? Proving the triangles congruent. So we have in this diagram, A and C, AB and BC. It looks like everyone see these two overlapping triangles that belong to those sides and angles. That's why I had the color pencils out, but if you didn't pick them up, it's fine. This might be the only overlapping one we do today. They're almost congruent. Everyone agree? They're almost congruent. I have a pair of angles and a pair of sides in your group. Can you find anything else? Can you find anything else that would be congruent, that would make the triangles congruent? Because I'm down to one more pair, right? You guys know I won't go over the 5 methods right now, but I always need 3 pairs of congruent parts. I already have 2. Can you guys find a 3rd pair on your own? And find it on your own, please. I already have 2 pairs down. 1 more pair to go. Anybody find that pair? Kara, what do you got?
Angle B is congruent to angle B.
There it is. Angle B is shared in both. All right. Angle B is shared in both. So we call that, again, I know it's been a week or 2 here, reflexive property. Good. Do we have enough to say those 2 overlapping triangles are congruent?
Yeah.
Yep. And I know you guys are like, where are you going with this? Oh, you'll see. Triangle ABE is congruent to if I go ABE, I got to go CBD. How's that look? Okay, I'm going to need a method, one of the 5 methods. Hopefully that's still a little bit fresh in our mind. I do have 2 angles on a side, so it's either angle side angle or angle angle side. If you guys cannot tell if those sides are in between or not, what did I suggest last unit? Draw it out. So again, before I ask somebody, I got B, C, D, and what did I mark here? B. I have angle C marked. I have BC marked, and we just did an angle B. So Connor, what's the method here
Angle
now?
side angle.
That should be angle side angle. Yep. Where am I going with this, right? Everyone agrees the triangles are congruent? All right. Help me out. From unit 4, if the triangles are congruent, so are all the parts, right? All the parts. All the parts are congruent, right? Including, watch this part. BD, which matches up with BD, should be equal to, what's its corresponding part in the other triangle? And that's CPCTC, right? Everyone should be pretty lucky right now. Your paper is not just bursting into flames with what you have written down in your statements right now. Seriously? Anybody see a problem? Anybody see a problem here? What did I tell you was true in the givens?
That they're not congruent.
And then now what are you telling me?
That they're. Well, you said that.
Whoa! That can't happen. That's a contradiction. No way can they be not equal, and then in the same proof they are equal. Everyone agree with me, right? That cannot happen. What led us to this?
The assumption.
What led us to this?
The assumption.
So what do we know about our assumption now? Ready? I'm going to try to do this slow. Our assumption is false, isn't it? Because it led us to. We know this is not true. We know this is not true because of the given. So that must have said the assumption is false. Ready? If the assumption is false, what's got to be true? If A congruent to C is false, what must be true? A is not congruent to C, which is what I needed to prove to you. Okay? So let's do this one more time. Everyone agree with me that's got to be false. That's ridiculous. You told me they weren't equal. Now you're telling me they are. That is false. What led us to this? The assumption. So that tells me the assumption is false. So if angle A congruent to angle C is false, what must be true? That they're not equal, which is what I wanted here. All right, so that's once I have a false statement, a contradiction, which I do here in step 5. Now you can say, all right, if that's false, the assumption was false, so that means the opposite must have been true. Angle A is indeed not congruent to angle C. And here's our final reason in every indirect proof. What led us here? Okay, basic assumption. Assumption led to a what do we call that at the beginning of class today? When a contradiction led to a contradiction. And that's great. And what class are we in? So I want one little thing that shows me you actually know what the heck is going on. Over here next to it in brackets, I want to know the steps where the contradiction occurred. What contradiction are you talking about? Well, the one was in the givens, right? BD not equal to BE. And where did we contradict that? In what step? Step 5. So I want to see what 2 steps you contradicted yourself in. And yes, one will probably be the given.
Wait, in all proofs from now on, you want to see?
No. Just the indirect proofs.
Oh.
Just if you're doing this indirectly. This is a special way to do this proof because I was asked to prove angle A not congruent to angle C. So before we even sniff the next one, breathe this in, ask some questions if you have them, and I want to just summarize this before we move on to the next one. Question for you. How do I know to do a proof indirectly now? Abby, what do I need to see?
The proof statement is like saying something doesn't.
Correct. I look at the proof and I'm asked to prove something's not happening. It might not be not congruent. It might be something else, but I'm showing something's not happening. Perfect. How do I start it after the given? I write down the assumption. Where do I get that assumption from? Because here's where we start separating ourselves. We're doing it incorrectly and doing it correctly. Where's the assumption come from? The proof statement, not the givens. The proof statement. You do the opposite of the proof statement for your assumption. Now, I did not talk about this, but let's talk about this now. What is your goal of every indirect proof? Contradict yourself, right? And I'll let you know right now. You know where that contradiction is going to come from? One of the givens. Look at the given. Probably whatever is not equal to, we're going to contradict that statement. Okay, I guarantee it. That's the goal of every indirect proof. Contradict one of the givens. All right, Sophie, go.
Will the assumption always be the first step that you would do?
It can be the first or the second.
Okay.
You can write given, assumption, given. But the assumption's got to come before I start the proof.
Yeah.
Okay? All right, let's see what we got now. 1 doesn't make you great. Let's see what we got in number 2. All right, time out. Whoa, before we get going, I want to hold your hand on this. How do I know to do this proof indirectly? I'm not going to tell you in the test or regents or midterm. How do I know to do this one indirectly? I'm asked to prove
That something
does not bisect. So that tells me indirect. I write my givens down. Now it's time for my assumption. What do we assume is true in this one now? Zach?
BD bisects AC.
BD bisects AC. We're going to assume that's true, and we're going to see where that leads us. Before we even sniff number 3, though, make a plan. Remember, you want to contradict yourself, right? Look at the givens right now. I have ABC as not isosceles, and I have BD as an altitude. Out of those 2 givens, which one do you think is the easiest to contradict?
It's not isosceles.
It's not isosceles, because how do I contradict that?
By saying it is.
That's our goal. Say it again, Kira.
By saying it is isosceles.
Show me it's isosceles. We got a contradiction. That's false. Okay, so that's your goal right now. Show me it's isosceles somehow. Use your givens and use your assumption to show me it's isosceles. Okay? What's up, guys?
Doing copy delivery early today.
Oh, fine with me. Thank you, guys. Have a good Thanksgiving. High five and get out of here. Let's go. There you go. Thanks, guys. All right, so help me out. Make this triangle isosceles so I have a contradiction. Ooh, I put a little vocab word in there. Altitude. Yeah, that's going to be there. All right, I don't have anything here. Help me make it isosceles somehow. Anything you know is true. You want me to start writing down? Anything you know it's true. How do I make a triangle isosceles? We should probably go over that. Show it's got 2 sides or... Oh, you're not going to do that unless you know what about these 2 triangles. Okay, so everyone see a plan. Make the triangles congruent so I can have 2 sides or 2 angles. How do I make them congruent? Gage, you want to throw something out at us?
Definition of bisected.
Okay, to say what?
AD is congruent.
Okay, AD bisects AC, not the angle. So good job, Gage. AD congruent to DC. Definition of a bisector. All right, Gage got us a pair of sides. Good job. And you know what I like he did too? Use your assumption as a given. All right, everyone always just writes the assumption and forgets about it. Use it in the diagram. Use it, use it. What else can I mark on my diagram? Kira?
BD is congruent to BD.
All right, somebody's got to do it. BD equal to itself. I love it. Done. I got 2 pairs. Will, what's good?
ATB and BGC are right angles.
Oh, we know some little vocab from this unit. Altitudes perpendicular to the opposite side. So yeah, I have right angles here because BD is an altitude. So we're going to say angle BDA and angle BDC are right angles. Now, hey, this is the first time we're doing this. Take a peek. Take a peek. Usually it's perpendicular lines form right angles, but I didn't have perpendicular lines. Instead, I had an altitude. So I can write definition of altitude. You can say altitudes form right angles, but I can't say perpendicular lines form right angles because I'm given that word altitudes now. Definition of altitude. I know it's been a while since we've done some proofs. If you're going to tell me they're right angles, you better tell me what.
They're congruent.
They are congruent in the next step. Oh, I know you missed it. You got a little break from them. You missed it. Right angles are congruent. Oh, this is going to be a deep one, huh? All right, so I think I got all 3 pairs. Anybody see anything I'm missing? I got a pair of angles and the sides around them. Triangles congruent now?
Yes.
Indeed they are. Move this up a little here so we can get them congruent. Triangle BDA, or however you want to name it. Congruent to, if I go BDA, I got to go BDC. Side angle side. Gosh, I should have asked. Sorry. Hopefully nobody's disappointed by that. Why do we need the triangles congruent? Let's keep going. What was our goal? If I wanted the triangle so I could get either Gage.
Angles congruent.
angles or the sides. You choose right now. Okay, you choose. Our step 8 could be different. You either tell me in step 8, you tell me angle A congruent to angle C, or you tell me AB congruent to BC. Either one's going to make an isosceles triangle. I'll go sides. AB congruent to BC. CPCTC. Ooh, what is this now then? Be careful when you write this on your paper. Hopefully no sparks happen. ABC is isosceles. And we always wrote down definition of isosceles. Some of you guys write 2 congruent sides, 2 congruent angles. That's fine. I just write definition of isosceles. And now we have a problem. Right? We have a problem when we write that. There's no way that can happen because what we were given. So I'll do this again. We'll do this again to make sure you understand how we know the proof statement is actually true. We know this is false because we were told it was not isosceles. So this is false. What led us to this?
Assumption.
Which has to be false as well. So our assumption has to be false. If our assumption is false, what's got to be true? The opposite, which is ABD does not bisect AC. Ten steps, huh? Buddy feeling like a boss? Just me? Okay. And it's the same ending every time. Same ending every time. Assumption. I forgot to mention this. Led to a contradiction. All right, where did that contradiction occur? It's always one of your givens, right? Always one, so you should always have, well, again, I always say number 1, but if you put your givens in number 2, that should be number 2 then, all right? So pay attention to where you put your givens. And then, Kira, what step did I contradict that given?
9.
In step 9, yep. And what I forgot to mention is, I know even in an honors class, sometimes we get lazy. I know, can you believe that? That's shocking to me too, that you get lazy in an honors class. There is no CPCTC version to assumption led to contradiction. Please don't give me ALTAC. All right, that's incorrect. There's no such thing as that. Okay, so get that out of there. All right, no ALTAC, please. Questions? Do we have to do another one, or you think you can breathe one on your own within your group right now? What do we think? What do we think? Still hold hands, or are you thinking you can get after this one? Well, I don't care what your answer is anyway. You're getting after it with your group. I'm putting the correct version up here so you can check it. If you and your group are good with my version, because there's really, other than the steps being in a different order, we should all have the same number of steps. Once you do have that and it all matches mine up here, go ahead and finish up the homework for tonight. All right, so you can talk it over, or some of you, it looks like you're just going to try it out on your own. Whatever floats your boat. Find your lost remote. It's okay if you struggle day 1. We got day 2 coming up. Monday I say when we get back, it's Monday. We'll have another day of this on Monday. Please remember what I just told Sophie about 10 minutes ago. It doesn't matter whether you put the givens or the assumption first, but pay attention to what you put in the brackets at the end. And before you start going crazy, look at your givens and say, all right, which given am I going to contradict? All right, and that should be your goal. All right, which given am I going to, and it'll be very easy to know which given you're going to contradict. An indirect proof. What were the proofs we have been doing? Direct proofs. You go right to the given. Or you go right to the proof statement. I'm getting 9 steps. Yep, Karen.
Is I also got 9 steps. Is
Yep.
it usually typically the step right before where you said
Better be.
the assumption led to a contradiction?
Better be.
That's usually the second one.
Better be. Because that's when your contradiction happens, and you can stop the proof and say, "Oh, now my assumption's false."
Okay.
Yep.
Just wanted to
Mhm.
verify.
And again, once we're good, you guys can move on to the rest of the assignment, which is a couple proofs.